In this video, we're going to talk about a method of factoring called factor by grouping. The goal of factor by grouping is to rewrite a polynomial with 4 terms as one with 2 binomials multiplied. It's called factoring because when you factor something, you bring it down to simpler terms that are multiplied together, a product. And that's what's happening here. It's this thing times this thing. So it's what we called factor form. So this process that we're going to learn today to go from the left to the right is called factor by grouping. So let's take a closer look at how that might happen. So the general strategy is to group the first 2 and last 2 terms together and find the GCF of each of them individually. Because out of all those 4 terms, they don't have anything in common, but when separated, they might. These have an x in common, and these have a 6 in common. So what you can do is take out those from each. So I'm going to really divide both of these by x, if you will. And then I'm going to take a 6 out of these, and that leaves me with a 4 here, and I keep my sign. And it's a little weird, but what's happening here is we have 2 groups of things, and both of those groups have an x minus 4, so it can come out too, like we're factoring. So we're left with this, and kind of magically, that's the answer. That's factored form. And if you want even more proof of why this is working, well, let's go ahead and FOIL, or that's what I call it, but you could call it distributing a binomial into another binomial. What happens? Well, we get x squared plus 6x minus 4x minus 24. And up to any sort of rearranging, these are the same, right? So it's FOIL. If you prefer FOIL, it's foiling and factoring are kind of opposites. They undo each other. They're inverses, really. So I want to emphasize that again. So this orange term here, it comes out. And for this first grouping here, you're left with the 3x. And over here, you're left with the 2. So it's really about taking that whole thing out because it's in common for both of them. And that can happen here too. These both have this x plus y term. So that can come out. And they both have a 3 as well. So that actually takes out everything from this one. So we leave a 1. And out of this first grouping of terms, we lose a 3. So it's going to be 2. And then all of this stuff stays because it was not pulled out. So even with something more complicated, you can always, pulling out a binomial is a fair strategy. All right, so let's again break it down into steps so we know how to do factor by grouping. So once again, we're going to separate. We're going to factor out something that's in common between each pair. And at this step, we're always looking for what we could call a common binomial. It should always match, because then we can take it out and then we're done. Okay. Some things to be careful of, though. 2 things. If the third term is a negative, you want to take out that negative. And as we saw a little bit earlier, when you take out, or rather, if 2 terms have nothing in common, you can't take out anything. So what we do is we take out a 1, which you can always take out a 1 of anything, because 1 is special like that. So let me show you. This is going to talk about the special considerations. So group, the first 2 have an x. These last 2 have a 2, so it's going to be x and 9, because when you divide those by 2, that's what you get. And so the consideration, the reminder says, hey, you should take out that negative as well. So we'll go ahead and do that. And then that would actually make this a plus. So, and why is it plus? Because, well, if you distribute this backwards, we want to get minus 18. So it has to be a plus. And notice that if we didn't take out a negative and somehow just took out the 2, we would have 2 binomials that are not the same. And we don't want that. So the trick is take out the negative and everything should be okay. So we get these two by taking this thing completely out. All right, another example, and this happens to work for cubics too. So out of the first grouping here, we've got a 2x squared because they both have an x squared and they both have a 2. So you can take out all of that. That wipes this out completely, and we just have a 1. But this one we're left over with a 2x. And this again is a little weird because there is nothing in common between a 2x and a 1, especially 1. 1 never has anything that can be pulled out, right? So if that happens where you have, these are called, the term for it is relatively prime, right? They don't have any similarities with themselves. They can't, so they're kind of, anyhow, sorry, I'm getting a little lost in what so basically you can't do anything, but the strategy would be to take out a 1 because that allows us to continue with our process, because then when we take out this term, we're left with 2x squared, but then we have something to write here, right? So there is a 1 there that you should be encouraged to take out. So in conclusion, we've studied how to go from 4 terms down to 2 binomials multiplied. How do you do it? Well, you group the first, you find the GCF of that. Okay, this happens to be 7x, and then 3x and 6, they both have a 3. So we're going to take that out in addition to that negative sign. Remember, that was one of our special considerations. And then you take out that binomial term, and then you're factored. And that's what matches what we anticipated right here. So in the future video, we're going to talk about how to factor something like this, which feels very different, but these are actually the same thing. So what's called the AC method is going to give guidance to this era, which says, how do you take a quadratic that has 3 terms and break the middle one into 2 and then do factor by grouping? Okay, so that's actually a preview to the AC method video that's also posted.